Welcome everyone. It's great to have you back here for those of you who have been joining us for previous sessions, and wonderful to see some new faces as well. This is episode 4 of our 6-part series on enabling open science through research code. Previous episodes included a general conversation with researchers who code, enabling reproducibility through research code. Last month, we spoke about opening up research code, so talking about licensing and other practices to make your code more open. And today, we're continuing that conversation and talking about how documentation can help you to make your code more usable to yourself and to others, which also, in the end, supports the opening up of your research code. So last month, we already had some comments referring to the importance of documentation. And we had some comments about different levels of documentation. And I'm very excited to introduce you today to our speakers who have all indicated a strong interest in research software documentation, and have some different experiences that they're going to share with you, and hopefully some practical tips and tricks that you can also apply. I do want to encourage everyone in the audience to please feel free to share any resources, any ideas, any opportunities that you know about that others can learn from us as well. I'm by no means an expert on research documentation myself. So we would love to also learn from you. I think there's a lot of people with very good experience in the room as well. So please, we do ask if you have anything useful to share, if you have any questions, or if you want to contribute to the conversation that we're having with our panelists, you're very welcome to use the chat. The four of us, Mireille Grobler is also in the audience, and she will also help us to monitor the chat and respond to that and also highlight the questions. Should we not be able to address your questions today in the session, we will still make a note of them, and we will respond to them either via blog or in our resource document, which we will be sharing. So that the resource document is also part of the agenda that Jati's been sharing kindly in the chat. So you're also welcome to post questions or resources into the document directly. And then afterwards, we'll make sure that that document is also shared with everyone who is in this session, but also to people who cannot participate. So whatever you share here today will definitely be available afterwards, and will also be shared with people who are unable to join the session. I'm Anelda van der Walt. I'm the director of Telarify and a co-lead for RSSE Africa, and have been working with RSE Asia and others to help create more awareness of resources and opportunities around research software at all levels, from just coding for own analysis up to more widely used research software. And then so Saranjit and Jati, please, if you can also introduce yourself, and then we'll hand it over to the speakers. Thank you.
Thank you, Anelda. Hello, everyone. I'm Saranjit. I'm a research software engineer at Imperial College London, and also the co-founder of RSC Asia Association. We founded this community in mid-2021, and since then have been looking for ways to engage more with the community. And with this 6-part series with RSSE Africa, we have been able to generate some momentum and gather some interest on different aspects of research software and research code from our audience. So that's me. Thank you. Over to you, Jyoti.
Hello, everyone, and welcome to the session. My name is Jyoti. I have a background in statistics, and I also work as a community manager for Research Software Alliance, which tries to promote research software. And I'm also co-leading the RSC Asia Association, and I have been contributing to the community, and looking forward to the episode today.
I'll invite Jenny to introduce herself.
Saranjit. So yeah, I am Jenny. I will answer these questions that you've put up on here. So my background's in mathematics. I did my bachelor's at the University of Leeds in the UK. And then after that, I did a PhD at the same place as well, in fluid dynamics. So for my PhD, I used numerical models to simulate iron snow in the deep interior of our planet. Good times back then. And now I am a product manager at the International Interactive Computing Collaboration, otherwise known as 2I2C. And in my role, to put it briefly, what I do is provide a bridge between users of our platform, so that user experience, and I bridge that with my sort of technical background and expertise to help drive forward and develop open source software that can enable research and educational communities to create and share knowledge with interactive computing.
Hi, everybody. My name is Joel Nita. I'm an associate professor at Chiba University in Japan. My background is in evolutionary biology. I'm particularly interested in ferns, and that is my current subject of research, the evolution and ecology of ferns. And I'm also very passionate about reproducible data analysis and open science. And to that end, I'm an active participant in communities like the Carpentries for helping researchers teach researchers best practices for data analysis, as well as R Open Sci. So my programming language of choice is definitely R. I use it pretty much every day. So I'll give it away right now that my perspective in this talk or this panel is definitely going to be from R perspective. So I'm also active in the R Open Sci community. I've developed some packages and reviewed packages there. I think my educational background. So I got my master's at the University of Tokyo and my PhD at Harvard University. So I think that covers most of the questions. Thank you. So pass it on to our last panelist.
Good morning, colleagues. My name is Mteto Sovacha, and I'm currently working at the Center for High Performance Computing in South Africa. So my role involves facilitating research by installing and optimizing software for Earth system science, weather and climate modeling, and astrophysics, ensuring that these applications run efficiently on our HPC systems. I hold a master's in ocean and climate dynamics from the University of Cape Town in South Africa. I'm currently pursuing a PhD in oceanography at the same university. My work focuses on advancing computational methods in climate and ocean modeling, and my work further aligns with my passion for utilizing cutting-edge technology to solve environmental challenges. Beyond my research, I'm committed to supporting the growth of computational skills in South Africa. I've contributed to the student cluster competition and coding and robotics training, helping to inspire and equip the next generation of scientists and engineers. And I look forward to collaborating and learning from all of you. Thank you.
Thank you so much, Mateto, Joel, and Jenny. We have a very diverse range of panelists today, also joining from different parts of the world. So it's going to be a great and interesting conversation. Let's kick off the session with the very first question to our panelists. This is a question to Jenny and Mateto. So I'll also be putting the question in the chat so that it's easier for you to follow. It says, why is documentation so critical for research software? and how does it influence the reproducibility and longevity of research outputs? So we are talking about or about to discuss about what is the importance of documentation and why you should be documenting your research software or research code. So over to Jenny and Matheto.
Yeah, so I can have a go at this one first. So documentation is really critical for research software because it's the first point of access. You know, it's outward facing, it's a user-facing communication tool that people first see when they stumble upon a research software project. And so this influences, as you say, reproducibility and the longevity of research outputs, because no one will be able to operate your research software if they don't understand from documentation how to run it. Often, like research software can accompany a research paper, for example, but there's not enough, space or time, or it's not the appropriate place for a journal article to really expand upon how you run a piece of research software. So that's why good documentation to address this aspect really increases the value of your research output because it helps people, again, reproduce your piece of work themselves independently, and opens the door for future development, collaborations, etc. Yeah, I can pass to Joel.
Thank you, Jenny. So by definition, code documentation is a written explanation or set of instructions that accompany software. And this is important because it helps others to understand and work with your code effectively. And so it serves as a reference guide, offering insight into the purpose, functionality, and structure of the code. So documentation is critical for research software because it ensures that the code, the methodologies, and the results are understandable, reproducible, and usable by others. Without documentation, even minor misunderstandings, for instance, missing dependencies or unclear formats, can prevent others from replicating your work. So essentially, documentation promotes collaboration. Comprehensive documentation helps new collaborators or team members quickly understand the project. Documentation also enhances longevity, as Jenny has highlighted, by ensuring that the code is usable long after the original authors have moved on. Moreover, clear explanations of the code, the structure, and the purpose make it easy for future researchers to extend or modify the code for new studies. So in closing, investing in good documentation is critical as writing robust code. Both are fundamental to advancing science. Thank you.
Thank you, Jenny and Matheto. I think you're making very practical points there. Like Jenny said that all the stuff that you code may not appear on your research paper when you publish that paper. And so there is a high chance that a lot of knowledge is getting lost when you're trying to write that paper and just use the results from your research code. And also, Matheto was saying that if people move on to, say, a different project, anybody who's working on that project next might struggle to pick up on the work if the code is not well documented. So I guess there are very, very practical points there. I'll pass it to Joel because he's raising his hand. Joel, you wanted to add something?
Thanks. Yeah, I just thought those are all, of course, excellent points, and I totally agree with that. I would also just make a distinction when we're talking about documentation. I kind of think that there's, broadly speaking, maybe two categories. Like the user-facing documentation, we're talking about the instructions that are given to people who want to use our software. And then I think there's also the developer-facing documentation, which is things like comments that you write in your code so that you can understand that a user is not necessarily going to see, but you as a developer need to be aware of. And they're both, quite important. And I think in our sort of agenda of talking points, one of the sort of sub questions to address in this first section is an example, perhaps, where well-documented research software has led to collaborations, or so an actual real-life example of some of the things that were mentioned there. And for that, I would actually point to one. I can speak personally about this sort of experience. As I mentioned in my introduction, that I've been active with a group called rOpenSci. If you're not familiar with them, I highly encourage you to check out their website. Grab the link here, ropensci.org. And so it's a community of R developers and programmers who develop packages together, which are for research computing. And so I've developed my own packages from scratch and submitted there. I have also taken over a package from somebody who started it and then had to walk away at some point. And in that case, having that well-documented code was super important because, I mean, usually the reason they're handing it off to somebody is they can't, be involved anymore. So you don't want to be in a situation where you need to be emailing them, being like, hey, how does this work? Because that kind of defeats the point, right? So it's really important to write your code well documented, or to document your code so that someone can come at it and be able to work through it without actually having to ask you further questions. Like it should all be there ideally. So yeah, that was what I wanted to add.
Thanks, Joel. You almost answered the next question that I was going to ask. Do you have any examples where well-documented research software has led to unexpected collaborations or extended the impact of the work that you have been doing? If you wanted to add more to that, or we can start with Mateto. Mateto, if you have any examples to share of well-documented research software and the collaborations that it has led to.
Thank you, Sanji. So I'll start with the international example that I think Jenny might know well, OpenFOAM. This is one of the software applications that we support at the Center for High Performance Computing. So OpenFOAM is a toolkit for computational fluid dynamics, primarily used in engineering research. And because of its user guides, its tutorial, and its vast community support, it has enabled researchers in non-CFD fields to adopt it. So examples are modeling air pollution, simulating blood flow, and drug discovery. Another international example is Scratch. So Scratch was developed at MIT as an educational tool to teach children programming through visual blocks. It's easy to follow. It's easy to follow guides, and community projects have helped it extend beyond its reach. This week at the CHPC, we are currently running a coding and robotics training to delegates from the National Department of Basic Education. We've been teaching them basic introduction to Scratch and how that can then be transferred to robotics. So this is one example where well-documented software went beyond its original intent. Another example is, this is a local one, because we have documented the workflow for the weather and research forecasting system WAF on our wiki page. The National Weather Services, the South African Weather Services, approached us to collaborate with them in writing a tender to kind of support the weather forecasting efforts of Ethiopia. And so they eventually went on to win that tender, and they'll be working on that project. So we kind of benefited because we just documented how to install and optimize WAF on our wiki page, and they approached us and said, hey, let's join forces and write this tender document. So, yeah.
Thank you so much, Mateto. There is so I'm going to get a question from the audience here. Also, because Joel was mentioning that there are two types of documentation that could be written, a user-facing one and a developer-facing one. And in the chat, we have a question that who should actually write the documentation? Because so there are two parts to it, like who should write which type of documentation, and then because researchers may not have so much time to write the documentation for code that doesn't really show an immediate impact. So who should be doing or writing this documentation really? Joel, because you were talking about two types of documentations.
Sure. So that's a really interesting and important question, I think, because of the way it was phrased, the last part, that researchers don't have time for things that doesn't have a clear and immediate gain. So I think that really actually hits the problem on the head, because that's how it often feels when you're writing documentation, especially developer-facing documentation and sort of notes to yourself, is that, well, I know what I'm doing right now, and I'm busy at the moment, so I should just get this done and move on to the next thing. But I think by writing clear documentation that you can come back and read later and understand what you were doing, it actually has really very high value. And so I think adopting that mindset perhaps is very important to answering that question, is understanding the true value of documentation. As far as who should write it, I'm not quite sure what you're trying to get at there. I mean, I think certainly the person who is, writing the code should be writing the documentation as they go along. But at the same time, it is important, I think, for user-facing documentation to try to get feedback from people, because sometimes as a developer, it may seem obvious to you how to do something, but it may not be as much for the people who are actually using the code. And so, for something like that, by hosting your project on GitHub, for example, and having an issue tracker where people can submit issues and say, this aspect of the interface could be made clearer, etc. I think that could be really important. So yeah, I'm interested to hear what the other panelists have to say about this as well.
Yeah, I think it kind of runs into the next question, I think, that was coming up about how teams can balance time demands for research and coding. So I can sort of speak to that one in terms of yeah, you're right, like balancing research with anything is really challenging because you're so pressed for time and resources. I think it's always good to just have when you're starting out, just have the bare minimum, at least put a README file if when you're hosting your project on GitHub, like Joel suggested, a README file, a bare minimum to just describe what it is. And then a license as well, so that people can actually use it. If you don't attach a license to the code, then technically you can't, another person coming along can't use it. So just starting with the bare minimum and having that in place, and then kind of assess why you might want to extend the documentation. So from a developer point of view, is it because you want others to contribute and perhaps collaborate on this piece of software in the future? Is your motivation to secure more funding? Is it coming from an academic grant? If so, then it might be, more useful for your time to focus on that side, that side of things. Or if you're trying to secure, funds and resources from a more infrastructure or software related grant, then you might be like, okay, well then, I need to invest more time and resources to make sure that this piece of software is resilient and reusable by others. And then sometimes it might be something else that might motivate you. Is it actually speaking to your core values as a researcher? If you're a practitioner of open science, if you want to produce fair software, then documentation is a part of your process in order to keep your work open. And so, yeah, I can sort of speak to a specific example from my sort of my PhD or like postdoctoral studies. So I mentioned in my introduction that I worked in fluid dynamics and simulating the Earth's deep interior. And these codes are very complicated. They run on high performance computing, and they don't take like a month to write. These are like pieces of software that take years and years of development and collaboration. And so there's a lot of like competing what we call like dynamo codes to simulate this from different research groups. And I found that the most popular one was the one with accessible documentation because people could see the science, the equations, and also like marry it with the methods. And then they'll be like, oh, it sparks an idea for their own, research paper. And they take that piece of software, and add another module or functionality to it. And boom, you've got, a new piece of like research. Whereas like other competitor codes were like not visible. Like you would just like your supervisor would just email you this piece of code and it got shared around in that way. There is barely any documentation to go with it. And so like there weren't as many I mean there were some, but it wasn't as popular as the one with the user facing and developer facing documentation to go along with it. And naturally it built up more citations and, there was a bit of momentum, there is and still like momentum with this more popular piece of software. So yeah, that's my like sort of general background and then also a more specific example of what might motivate you to try and sort of tip that balance into investing a bit more time to sustaining your software for future collaborations.
Thank you, Jenny. That's all very valuable and very practical input that you're giving there. As you were talking, I was thinking, and based on the question that I think Diego was also asking, who should write the documentation, and then he was also giving an example that if there are professional research software engineers involved in development of the code, they might not have the knowledge of the user base to write very good user documentation. They might be good at the technical documentation, which you also now refer to. And it seems like both of those types of documentation are quite important. I know in our audience, we have people who are not specifically writing code that they think will be used outside of the scope of, for example, their own specific research project by themselves. So there are researchers who code in the audience for their own purposes. And at the same time, we've got people like yourselves who are developing code that are definitely going to be used outside of the scope of their own research and their own research groups. So maybe just if we can stay on the topic of balancing time demands and quality documentation, specifically for people who are new to coding and who are writing code just intentionally for themselves, but you never know where that code might go, as we all know who's been in the field for a little bit longer. What tips and tricks can you give them to that as they are coding, to make their code more user-friendly for themselves, which may also set the code up for usage beyond their own work. And even if they were to submit their research as a publication and reviewers wanted to look through the code, that reviewers could make sense of the code or evaluate it a little bit as part of the review of the journal article, for example. That's my one question, because I know we've got people in the room who could benefit from suggestions like that. And I think writing documentation retrospectively is probably the reason why so little documentation exists for many projects. So yeah, I'll leave it to you. I don't know, Joel, if you want to weigh in there, and then we can give some of the other speakers a chance as well.
Sure. So yeah, I think writing clearly well-documented code and just clear code in general is a bit more of an art than a science sometimes. That is to say, I think you know, as a beginner, it can be challenging because it's something that you get better at with time and as you gain more experience coding. And so I don't think you should be necessarily discouraged if it feels difficult at the start. That it's something that I think any of us are always, you know, feel like we're probably gradually improving and getting better with. That said, I may be able to share a few tips. So for kind of maybe for people who are earlier in the process, one is to try to write code that is, even though, so when we say documentation, that's often means, you know, comments, but I don't think it's only comments, because you want to write code that is hopefully legible, that you can just read the code itself and have an understanding of what's going on without needing comments. So for example, using variable names that reflect what they actually contain instead of something like X or Y or res or dat. So being, you know, maximally explicit about what the code is doing. And one technique that I've come across through my, again, and this I saw posted by a software engineer by the name of Maëlle Salmon in our OpenSci. One suggestion she had is you can even write, if you use a function that has an obscure name, you could write a wrapper function for it that has a much clearer name. And all it's doing is taking that input and passing into another function, but you give it a good name so you know what it's doing. And then every time you use it subsequently, you're like, I can read this and see what's going on. And so I'll just go ahead and share. So those are just a few tips. And she has some great slides with those and some others. So I'll go ahead and share those in the chat right now on writing, I think she calls it writing beautiful code. So yeah, that'll be it for me.
Fantastic, thank you. Tito, do you have anything to add there? For, as I'm saying, specifically for people who are writing code for themselves, what can they do to make the code more user-friendly for themselves? Because we know you'll be writing something today, and then in 3 months' time, you get a new data set, you want to run it through the same code, or you find out that you misread something, or you want to try something new, add something new, and you can't remember what you did in your code. How can people help themselves by writing some documentation for their code?
Thank you, Arnelda. Couple of things from me. First and foremost, and most important, take-home message is plan documentation early. Document as you code. I'll say it again, document as you code. But another point is to consider the audience for which you are documenting for. As Joel mentioned earlier, it's important to consider who the document is for. Is it for developers or end users? Another point is to use consistent and clear inline comments that explain the why rather than the what. We've also heard about README files in GitHub that explain instructions, how to use the code, and the purpose of the project, just to add some context. It's also important these days to leverage automatic documentation tools like Cursor. And I will say right now that Cursor is a game changer for RSCs. Check it out. We can also use flowcharts and diagrams for complex workflows. But it's also important to test and validate your documentation. Walk through instructions to ensure that they are correct and complete. And also ask a team member to test. Lastly, it's important to maintain and update the documentation regularly.
Thanks, Mtetu. Again, very useful comments there. Mtetu, Joel's just asking, what is the tool that you just mentioned? Was it Cursor?
Cursor, just type, I'll put the link on the
Wonderful.
chat.
Thank you. So
Thank you.
this is a little bit of a segue into, again, the question that Diego asked is who's supposed to be writing the code? And as I'm listening to this conversation, I'm hearing that there's definitely, no, not definitely. It seems to be like that for the person who's writing the code, there's more value in writing documentation in a technical documentation than what there is motivation for you to write documentation for users, because you might be your own you might be the user of your code and you know what your code is going to do, but it might be more useful for you to know how to extend or modify or reuse the code for yourself or for other developers. So maybe the technical documentation we've discussed a little bit, write it as you code, plan it beforehand, and then there's different levels. You can do in code comments, you can do readmes. There are other levels of simpler documentation that you can do with at a lower level with a lower time commitment. And then there are more cumbersome and advanced ways of doing technical documentation as well. But one of the conversations that's been ongoing, and I'm going to put a link in the chat here, has been at a funder level. And what I'm putting in the link is the adore.software website, which is the Amsterdam Declaration on Funding Research Software Sustainability. And I think the conversation that we're having here about documentation is something that should be brought to the attention of those people who fund research software, because it seems like documentation is not necessarily something that is explicitly considered when people are thinking about writing code, and especially then the user documentation. So immediately as people were thinking, I was thinking, oh, so maybe you could have almost like hackathons to write user documentation. If you bring together a user base, people who are using the software, to bring together and say, okay, let's look at this user documentation. What would you want to change? What do we need to add? Let's take a day or two and update the documentation together. But those things cost time, and someone needs to organize them, and someone needs to like make it happen. So for those of you who are in positions where you can speak to funders, or where you are applying for funding, think about how can you include documentation as part of your funding applications. And then also there are opportunities to bring this to the attention of the funders through initiatives such as the Research Software Alliance's Funders Forum. I'm going to give you a link to that now. So Research Software Alliance is a global organization that works with funders and decision makers in terms of research software globally. Oh, I said global already. And they host the Funders Forum. And these funders get together once a year in person or hybrid and discuss policies for funding research software. So this is, as I said, we sidestepping a bit the conversation, but also talking about solutions to problems that we have with software documentation. So let's bring it back. So we were talking about tools and platforms that can make research software documentation easier. Is there one of our panelists who would like to contribute some ideas about tools or platforms that makes documenting easier? And Mtetu's shared cursor. Jenny?
Yeah. So I saw in the chat, Anelda, that you mentioned things like Jupyter notebooks or using R Markdown. I don't think we've talked about Markdown explicitly so far in this conversation, but that's just a very useful way. It's a very lightweight way of marking up text or like, that, written words. So like how you can um basically, Markdown is very useful because in a Jupyter notebook, you might want to put pieces of narrative text next to, like directly next to pieces of code. And that helps you in one way document what you're doing as you go along. And you can format that text using Markdown, and it's very lightweight and simple. So you can like introduce headers, bold, you can like write mathematics as well. So you can there's some LaTeX plugins to write mathematical equations. So it's very powerful to marry those two ways of explaining your code and content together. But that's that. I think Jupyter notebooks, they're very much part of like the Python ecosystem. I don't think people really know that you can use it for with R kernels as well. So if you're interested in using notebooks in that way, you can use an R kernel or a Julia kernel for your computations. But Joel, you might want to use something a bit more like R Markdown or like something like Quarto, for example, if you want to um uh write narrative along your code at the same time. Um, and yeah, I know a lot of researchers who do a lot of their work in Jupyter notebooks so that they are leaving those crumbs for themselves, like at the end of the day, you'll always have the audience of yourself, right? When you're writing documentation. And I know that I've written code from even like 3 months ago, and I look at it and I'm like, what on earth was I thinking? Like, why did I write this function here? Like, what does that even mean? Um, and so it's really useful just for yourself and your productivity, really, to leave these little notes to yourself. Even if it's an audience of one, so that you can just pick it up in the future, like 3 months down the line, even a week down the line, or a year down the line. You might have to brush off your research and try and rerun your simulations all over again. So thank you for linking the links in the text, Anelda. But yeah, I find these tools very useful for writing as you're going along.
Right, Joel, did you want to add something there?
Sure. Yeah. Thank you. I put a bit in the chat about Quarto. And yeah, highly encourage people to check that out. It's sort of like the next generation of R Markdown, but it goes beyond R because it is multilingual. You can also use Python as well as Julia and other, I think that is correct. Any other languages in there as well. And I think this is maybe deviating a little bit from strictly like software documentation, but I think it's also quite related to just reproducible science in general. Is that another way that I think you want to approach a project and documenting a project is to have code that requires actually a minimal amount of manual fussing around. Ideally, you should be able to come back to a project and run one and give one command that will then execute everything and make sure that your results are in sync with your code. And there's various tools to do that, such as Python. I believe SnakeMake is a popular one, or like Nextflow for genomic analyses. In R, I'm a big fan of Targets, the Targets package. And so when you use that sort of software to orchestrate your analysis, at least with the one that I'm familiar with, Targets, you have a file that describes the entire workflow. And so again, this is this idea of having code that is itself legible, that is self-describing, that the code itself tells you what it's doing. And so when you write it that way with the workflow of steps, it's very clear what you're doing. And then each of those steps is itself maybe a separate function or a separate file that if you needed to go and look at the details of what's going on, you can do that. but having it defined in a workflow and using that sort of package or software gives you a high level picture of what's going on. So it's easy to come back to it later and understand what you're doing.
Thank you so much. Nteto, is there anything else that you would have liked to add to that? You've already shared a lot.
Yeah, no, I
Thank you.
think the colleagues, yeah.
All right. So just again, an invitation to our audience for those of you who have come across nice tools or useful references for writing good documentation, please feel free to share it in the chat, and we can also share it with others. And we all just learning together, learning from each other. I'm going to hand over to Jyoti for the next section. Thank you, Jyoti.
Thanks, Anilda. Taking the momentum further, I'll share the next question, which is, what role do collaborative and community-driven efforts play in improving research software documentation? And this question is for Matheto and Jenny. I've also put the question in the chat for your reference.
Okay, I'll go first. So collaborative and community-driven efforts enhance documentation by, one, expanding expertise and perspectives. So diverse perspectives we know can drive innovation. And secondly, multidisciplinary inputs often lead to easy accessibility by end users. Improved usability then reduces the learning curve, encouraging wider adoption of the software. Thank you.
So I can definitely provide sort of an example of like recently that I think Anelda, you mentioned something about hackathons and like bringing communities together to sort of like focus time on improving documentation. Like one example community that I've worked with who do this in a sort of geospatial context is Project Pythia. So I've just put a link in the chat. And they organize hackathons on an annual basis. And it's basically 1 week where they just bring together a whole bunch of people, you know, academics, postgrads, students, and I had a brilliant time. Like I provided sort of like the technical expertise on how to use the tools. So we used a tool called Mist, which is kind of an extension of like a different version of Sphinx. I've not even mentioned Sphinx yet, but in the Python ecosystem, Sphinx is a very popular tool for writing documentations for software. So we used an alternative version called Mist, which is a bit more of like a next generation version, which is focused on a bit more research software. And so I introduced the community to using this tool, and we, you know, hacked people's existing what they call cookbooks in the community, where they had their own cookbooks on like, you know, radar sensing, satellite, processing satellite data, a whole range of things. And yeah, they got together to improve bits of the documentation or work on how to host their documentation. So you can also use GitHub to host a website and publish a website for free using a github.io domain. So you can publish a website of your documentation through GitHub, for example. And it was really great because there were so many different things that we could tackle in that 1 week that I won't go through an exhaustive list. But it was really nice to kind of sort of see what the needs were from the researchers in terms of like making their science more open, and how sort of from my point of view, how the tools can meet that need and how I could develop the software to provide more functionality for what they want. So one nice thing about Mist, for example, is whenever you can link to sort of DOIs or Wikipedia, you can hover over those links and it will pull in some data from there. So it can preview, say, like a stub of a Wikipedia article in the same window, and there's a hover box that pops up. I don't know if I'm doing this description justice, but can pop a link in the chat, and you can sort of explore the kind of capabilities of how to bring your documents to life, with and publishing um, your your documentation online on a website. Um, yeah, that was really cool. And yeah, it does take resources to organize events like this. But if you do look at the Project Pythia website, you can see the huge amount of like the array of cookbooks that they've got out there. And it just enriches the community overall because your documentation could serve other purposes as well. You know, it could provide the basis of like training and workshops. There can be like multiple benefits of just having that for core piece of software and documentation that you want to present to others as well.
Hey, yes, Joel, please share your ideas.
I actually have a question for Jenny. So I'm checking out some of those cookbooks. They look really cool. And I noticed that many of them, or most of them, all of them have a binder associated with them, which is great. Um, and I was just wondering, I've used binder a little bit, but I found that pretty quickly you encounter memory issues. So I was wondering, like, are these sort of slimmed down versions of actual projects, or like how does that work?
Yeah, that's a brilliant question. So for those who aren't familiar with Binder, that is like a computational backend that you can use to um, provide a kernel to execute the code in your, sort of interactive like mist document, for example. And yeah, it's great to connect to a backend like that. But often, as Joel said, you'll run into some like memory limitation or computational limitation because the mybinder.org service is free. It's just volunteered. While the resources, the computational resources for that are limited because it's voluntary. But you can stand up your own Binder hubs on your own infrastructure, and then refer to that as well for your backend. So the Project Pythia community have their own instance of their Binder hub that we host for them. So we meaning the place I work for, 2i2c. Um, and there we have control over the resources in which you can provide. So we can have like, more CPUs or more RAM to demonstrate more intensive workflows that you often find in the geospatial community. So yeah, there's a lot of interesting ideas about that we're exploring at 2i2c on how to make that more like sustainable from sort of like a sustainable perspective in the terms of like we can't entirely rely on a volunteer community to provide a public binder service. So how can we like sort of provide ways, mechanisms, maybe authentication, so that people who are privileged in a certain community who are paying for the resources can actually access it behind, an authentication gateway. So yeah, it's a really interesting space as well. I think that's probably like taking us in a more like a different dimension, but it is one way in which you can marry like interactive computing with your documentation as well.
Great, thank you.
Would anyone from the panel or the audience like to add any ideas uh, about role of community in improving research software documentation?
I think Analda already mentioned the Turing Way community handbook, which I am a fan of, and it's not exactly documenting a research software code, but it is a very good example of collaborative efforts across the globe because I know quite a few people are like there are quite a few authors, like I think hundreds of them who have helped build this live document. And then I also shared a link about this global community of people who really love writing documentations. It's called Write the Docs. So you could find developers, end users, and different kinds of people from different kinds of background as a part of that community. So if you at all feel that you need some more encouragement when writing docs, I think that's a good community to join and be a part of.
And I think what's nice about the Turing Way and many other open communities is that they don't just share their documentation openly, they also share how they do things openly, which you can then apply in your own context. For example, what I shared was how they run their book dashes. So they've got, very, very comprehensive information about how they put together their book dashes, so that if you wanted to do something similar, you don't have to start from nothing. They even, if I remember correctly, they even share like the emails that go out to participants. If it's not this group, then it's another group, but I can find it.
All right. We have a question in chat which says, Peter says, I did a little bit of looking for project templates for new projects with spaces uh, for docs, tests, code. I didn't find one that I was 100% happy with, but some people might know some. So, any more thoughts on that?
Don't really have one that comes to mind in terms of like boilerplate, everything together like docs, test code, and etc. I think just because like I think the nature of the software I work with tends to be very modular, and I think that is the nature of like, open source software. So you'll have like different, I think we've mentioned a lot of different tools so far in this session, and it's about trying to stitch the right ones together. That's it for you. And Elder, you've just linked to Cookie Cutter. So yeah, that's one place where you can find a lot of different like templates and Cookie Cutter templates to choose from. That's a nice example.
Yeah, if I may, I would agree with Ginny that I have seen things kind of show up occasionally, and I think maybe some people do use them, but I personally also do not use a template. Sometimes I'll just look at my a different project and maybe do some copying and pasting and that sort of thing. I could possibly come up with a solution that might be more efficient, but I feel like every project is a little bit different, and so I have to customize things to the point where there's not that much point to it. And I think I asked in the chat there, it also, I think, would kind of depend whether you're talking about developing a piece of software like a Python or R package versus doing a research project. If you're developing a piece of software, the sort of the structure that you have to use is very, very is clearly defined and rigid, and there's tools to help you make sure you're adhering to that. Again, I'm an R person, so in R we have things like deb tools and use this packages that will generate a lot of that boilerplate for you and make sure that your package fits all the requirements that are needed, like like having a description file, et cetera, et cetera. So those are really helpful. But if you're talking more about a research project and how you organize that, I think it's could be a lot more flexible. But even then, I think there are a few rules of thumb that are very helpful. Like always, and in both cases, always have a README. For a research project, I like to have separation of my code and the data. And so I usually have some subfolders for code, and keep that separate from the data. And you want to make sure you commit your code to version control, but not the data. Some things like that. So I think there are some sort of rules of thumb you could follow, but thumbs you could follow. But I personally don't use a predefined template.
So
great conversation going on. So in interest of time, I will move on to the next question, which is for everyone in the panel, for Matheto, Joel, as well as Jenny. So the next question is, how do you envision the role of AI or automated tools in assisting researchers with documenting their software in the future? I've also put the question in the chat. Matheto?
Sure, Jyoti. A couple of things I can mention here that AI is, I've begun to leverage a lot of AI in my work now. And I've realized that, yeah, I can actually generate documentation on the same platform that I use to code and debug my code. And that recently is the application that I've shared called Cursor. So with AI, you can generate automatic documentation reports. You can use AI to do quality and consistency checks. You can leverage AI to transfer or transform code to diagrams or flowcharts. AI can also help with reproducibility support and testing. And AI can obviously help with making predictive suggestions. So in the long term, AI tools will begin to act as documentation assistants, seamlessly integrating into the research software development workflow. We've mentioned a number of tools that can be used to achieve this. Thank you.
Thanks for the benefits of AI. I think I want to sort of talk a little bit about how you should be cautious about using AI as well. There are some like sort of, for me, from my point of view, like I understand that it's it's a technology that we just can't avoid these days. But I still think it's worth bearing in mind the environmental impact of AI. So like to train these models, it takes I think like in a year, like 5 cars worth of energy usage from like using 5 cars in a year to train. Like that's a really rough measure. But there is a cost to using it. And so like if you want to use it, I would say with any resource, to be honest, like it's not just AI, like even when you're running simulations on HPC, just be mindful of like what is the actual like impact of your work on the environment. We are in a climate crisis at the moment. Another thing to bear in mind is concerns about sort of ethics. So make sure that you're not. I know it's hard to avoid, but it's something to think about. Is like what is this AI, the data it's trained on? So I think it's cool to use. I don't know. I wouldn't say cool, but like there's information that's public out there, but there's also like a danger of using data that is privileged or like copyrighted that goes into these tools. And then also just be careful about what you put in there. Like don't put any like private information in there yourself, or like any privileged information about other people. If you're working with sensitive data, if you're working in a clinical setting, um, be mindful and make sure you have like good policies around how you use this in a compliant way with the laws in your country. So yeah, I think I'm just putting a cautionary side of this perspective as well to the conversation, but I do understand that there's benefits for a lot of people too. Sure, we can wrap up, I guess.
Joel, what are your thoughts on this? So what are your thoughts about the role of AI or other automated tools in assisting researchers with documenting their software in the future?
Sure. Well, I think it's kind of funny that the question is in the future because I think it is happening right now, for sure. And I believe many people here have experience with this. And I do find it quite useful for especially for documenting functions. I will copy the code and paste it into the Copilot chat and say, document this function for me. It spits it out, and then I can paste it back in. And that is pretty, it is definitely a time saver, I will say that. I almost can never use it exactly as it returns it, because I need to read it and, often make modifications and perhaps some corrections. So certainly that's another point of caution, is certainly don't take it at its word. And I think the points raised by Jenny are very important. And I think with the way things are going, it's important to be mindful of that, and mindful of the fact that that software that you're using may have AI on by default, and it's an opt-out sort of situation. So you need to be aware of that, especially if you might have sensitive data that you don't want going to the servers of GPT, etc. To make sure you're cognizant of that, and turn it off if necessary. So yeah.
As a follow-up question to that, I would like to ask whether we need to also think about the licensing of the code while we upload the code to AI tools for documentation. Joel, Jenny, or Matheto, anyone?
Well, yeah, I mean, I totally agree that, as mentioned before, that including a license with your code was important before AI, and now it's even more important. So that should be one of the first things that you think about, perhaps after a README, or right up there with it, is including the appropriate license with your code. And maybe if it's privately on GitHub, you don't have to do it immediately, but certainly if it is public, then I think it's a must do.
I think we have had a great conversation. I'd hand it over to Anelda for any of her thoughts or for wrapping up.
Yeah, just on the AI topic, thank you, Jati. Perhaps we could also use AI for translating documentation. And again, as Joel was saying, where we are at the moment, and I wonder what the impact will be on people, because people don't seem to be too keen to read. And so I wonder how many people really read through the output of their prompts to AI before putting it out there. But we might have to get better at reading again, and critical reading, if we are going to be using AI so much. But definitely in terms of the conversations that we've been having in RSSE Africa, and for a while we were able to translate our newsletter to our bi-monthly newsletter to French, because we had a colleague from the DRC who was working with us, who translated the newsletter to French. But one of our biggest challenges that we've come across in terms of building community and building capacity and supporting the development of capacity building in Africa is language. And if documentation could be available in other languages, of course, that also makes code more accessible, and increase. It probably also might reduce the pressure or the impact on the developers for having to provide support to people who might not understand the documentation well because English isn't their first language. People are using the code incorrectly or running into simple problems because the documentation is only available in English. In very, very, very many cases, English is still the main language of coding and documentation. So language has been coming up quite a lot, and here it is again. And that's perhaps something where AI could help, especially in the languages where there are large language resources for, and translation is becoming more accessible. So we are at the end of our conversation. I don't know about you, but I thought this was really, really interesting. There were so many useful pointers, so many good questions coming from the community as well. we have a few minutes. So if there are any pressing questions that our community still have, we'd love to hear from you. While we wait to see if there are any questions coming through on the chat, Jenny, Joel, Mtetu, do you have any questions for the audience? Or for each other? Or for us?
Yeah, I could expand a bit more on the localization point that you mentioned at the end, Nelda. I think Joel, you also have a lot of experience with this with the carpentries, I think, like trying to translate curriculum materials for the carpentries too. I've had like mixed results, I think, with using AI, because the nature of research software can focus a lot on technical terms. So for example, recently I was trying to like translate material containerization using containers and images, all this kind of stuff. And so there aren't like one-to-one translations of these like technical terms sometimes. So you always do need like someone who has to like proofread and make sure that these kind of these like provide the context as well and some expertise for these translations. And I was wondering if you had any sort of similar experiences or how you've kind of come across stuff like this.
Yeah, thank you. Well, as you mentioned it and seem to be aware, yeah, I'm involved with translation at the Carpentries on a totally volunteer basis. But it's because I'm trying to get Carpentries more active in Japan, and we need materials in Japanese. And so our approach has somewhat shifted over the years because we've had this going on now for well over 5 years. And so at the beginning, we were not using any machine translation because it just wasn't good enough, period. But that has certainly changed recently, where although because of the problems you mentioned, you're not going to have something that is immediately 100% usable right away, but it can get you pretty darn close. And as a volunteer trying to do this in my spare time, I definitely feel this time crunch. And so having these tools available is very useful, but it's not a complete solution. So we still need to have humans in the loop, and how to integrate those two in an efficient way is something that I'm struggling with right now. So if you want more details about that, I'd be happy to discuss it, but I think I'll leave it there.
Right.
Thank you. That's really good. And I was just thinking, I was thinking about something and now I'm thinking about something that you said and I can't remember what I was thinking about. And I was reading what Peter was saying in the chat as well. He's posted there the Glossario project from the Carpentries, which is a term bank for data science terms in many, many languages, which people can also contribute to. And I remember what I wanted to say. A few years ago, I was working with a colleague from Saudi Arabia. People in the audience might know her, Batul. And she wanted to translate resources that were developed in the open life science community around open science to Arabic. Now, obviously, Arabic has more challenges than just the language. It's also the writing direction, the alphabet. So it was a very interesting project to be part of. But she actually partnered with a linguist to help develop terminology around open science that wasn't mainstream or just to translate correctly. Because often there are words in the language that that you can translate to, but there isn't a phrase. There isn't a known one word translates to one other word. So you can often translate using phrases and so on. But that was a very, very interesting project also just to see the realities of translating to languages where the concept isn't well established in the language already. So, and that's also something that we see in South Africa, where we have 12 national languages, one of which is sign language. So that's a whole interesting other question about accessibility and translation and language technology as well. So I think it is time for us to wrap up. Thank you very, very much to our panelists for joining us in January and committing last year already, and being here and being prepared, and just it was been a wonderful conversation. Thank you, Saranjeet and Jyoti, also for your help in preparing for this session. And thank you very much to our audience for your participation, your being interactive, asking questions, and sharing information. We are going to edit the recording, clean it up, and we'll make it available. And then we'll also share the resources that were shared in the chat or in the document. We'll make that document, tidy that document up as well. And we will share it. We'll make sure that it's emailed to you, and will be placed on the website as well. And then next month, on the 20th of February, can we be talking about February already? On the 20th, we'll be talking about the next thing, and that will be the topic of testing your software. And again, we'll be talking about a range of tests. So if you are just starting to code, you're just writing code for yourself, you're not writing code for other people, or if you are writing code which are widely used, we will look at different ways of testing your code at all levels of the software development layer. And then the last session for this series will be on the 20th of March, where we will specifically look at funding. And we hope that we'll be able to attract some of the research software funders so that you can also ask your questions directly to them. So we look forward to seeing you in February. Please don't be shy. We will see you on LinkedIn. If you want to share resources and opportunities, please make sure that we link up with you on LinkedIn. We can share it there with other people. Email it to us. We can also put it on our website and share it with our communities, the broader communities. Any final words from our panelists?
Thank you so much for organizing. I had a really brilliant time this morning.
Thank you for organizing, and to the other panelists for the great discussion.